When you talk about space, the speed is always mentioned in light years. Basically, it's in relation with light speed. But what would we see at the speed of light? Have you ever wondered about that? In fact, we see colors and everything around us because of light and how it reflects back to our light. This is an interesting yet difficult question to answer, and today on Soetial, we'll answer, what would we see at the speed of light? So, let's begin. First and foremost, let's clear that light does not always have to travel at such rapid pace. It could slow down depending on what it is passing through. The official speed of light is calculated as though it were moving in a vacuum. Differences in the speed of light are most visible in a prism, where different energy of light bend more than others, forming a rainbow. Surprisingly, the speed of light is no match for the enormous expanses of space, which is a vacuum in itself. Now, let's come back to our original question. According to Einstein's theory of relativity, as the speed of travel increases, objects appear increasingly distorted, with the view ahead getting gradually brighter. Then truly odd effects begin to take effect, with objects far ahead appearing to move further away while those behind appear to get closer. This effect is known as aberration of light. At light speed, there is eventually nothing but a blindingly bright spot of light surrounded by pure blackness. Weird. Now, we'll see what optical effects will appear when we accelerate to light speed. To begin with, Doppler shift will completely alter the hue of everything, with objects ahead of us shifting towards blue and ultraviolet, and those behind us becoming more red and infrared. The image will be drastically deformed as a result of Lorentz contraction paired with the changing time and distance it takes light reflected off objects to reach our eyesight. If you want to see what kind of distortions we'd see, you can play the free game, A Slower Speed of Light, which beautifully explains this concept. The acceleration will lead to special relativity effects, including time dilation, which will result in clocks measuring different times, and also length contraction, which will lead to objects appearing shorter in the direction of motion. And if you're wondering if we'll be able to travel at the speed of light, the answer is then no. We can never achieve the speed of light since it's an absolute speed. You can try to grab a light ray, but it will always escape at the same pace. Your spaceship will continue to speed indefinitely, and your field of vision will continue to contract until it forms an internally bright spot. The cosmos would be tremendously compressed in our frame of reference, like a thin fabric that we could cross from side to side in a fraction of a second. Although it's not possible, we can still model and compute what we would observe if we traveled faster than the speed of light. The curvature of space-time will deviate the route of light rays, resulting in the formation of a moving lens that divides in two. One part is moving ahead, while the other is retreating in the opposite direction. That was the video, guys. Like, comment, and share the video to show your love and support. Subscribe for more such videos. Thanks for watching.